Welcome back to our channel. Today, we'll be continuing with the chapter Mathematical Logic. Note that statements are denoted by the letters P, Q, R. For example, the sentence, 2 is a prime number, can be represented by P, that is, let P equals 2 is a prime number. Here, we come to the most important topic of this chapter: logical connectives. Logical connectives are also called logical operator or sentential connective. These are words used to connect two or more sentences in a grammatically valid way. There are 5 logical connectives. Before proceeding further with logical connectives, we need to know that the result of using these connectives to connect two sentences are compound statements. Compound statement is a statement which is formed by combining two or more simple statements, also known as substatements or component statements, with the help of logical connectives. Therefore, the truth value of a compound statement depends on the truth value of its component statements. Let's understand it better by studying logical connectives in detail. The first logical connective is and. However, other English words such as but, yet, though, still and moreover are also used instead of and, denoted with same symbol as that of and. Its symbolic form is P and Q, read as P and Q. Name of this compound statement is conjunction. It is the intersection of two sets in set theory. The second one is or. In mathematics, the inclusive sense of or is used. We'll look into it in detail in a few minutes. Its symbolic form is P or Q, read as P or Q. The compound statement joined with or is called disjunction. In set theory, it is the union of two sets. The third one is not. Its symbolic form is not P, read as not P or negation P. It is the complement of a set. The next is if, then. Its symbolic form is P implies Q, read as if P then Q or P implies Q. The name of this compound statement is either called conditional or implication. It is equivalent to subset in set theory. The last logical connective is if and only if or IFF. Its symbolic form is P if and only if Q. It is a biconditional statement, also called double implication. Basically, it is the compound statement of P implies Q and Q implies P of two compound statements. It can be read as P if and only if Q, or P is necessary and sufficient for Q, or Q is necessary and sufficient for P, or P implies Q and Q implies P, or P implies and is implied by Q. In set theory, it is the equality of two sets. Learn this table as it'll be helpful as the chapter moves further. The word or is used in English language in two distinct senses. One is exclusive and the other is inclusive. When or is used in the sense that only one of the two possibilities exists but not both, is called exclusive sense. For example, throwing a coin will get a head or a tail. Or, the amount should be paid by check or by demand draft. In the above statements, there is a possibility of only one of the two possibilities and not both. When or is used in the sense that first or second or both possibilities exists, it is called inclusive sense. For example, graduate or employee persons are eligible to apply for this post. Or, the child should be accompanied by father or mother. In the above statements, there is a possibility of all possible possibilities, of all possibilities. As mentioned earlier, the inclusive sense of or is used in mathematics. Now, let's find out the truth value of compound statements. While determining the truth value of a compound statement, we have to consider all possible combinations of truth values of simple statements and connectives. This can be easily expressed with the help of a truth table. In the given truth tables, P and Q are statements and TT, TF, FT and FF are all possible combinations of truth values. Here, remember that the conjunction is true only if both substatements are true, otherwise false. And disjunction is false only if both substatements are false, otherwise true. You should remember this as it is the basis of exercise 1.2. Let's begin with exercise 1.2. Express the following statements in symbolic form. E is a vowel or 2 plus 3 equals 5. Answer. Let P be, E is a vowel. Q be, 2 plus 3 equals 5. Then the symbolic form of the given statement is P or Q. Mango is a fruit but potato is a vegetable. Let P be, mango is a fruit. Q be, potato is a vegetable. Then the symbolic form of the given statement is P and Q. Milk is white or grass is green. Let P be, milk is white. Q be, grass is green. Then the symbolic form of the given statement is P or Q. I like playing but not singing. Let P be, I like playing. Q be, I do not like singing. Then the symbolic form of the given statement is P and Q. Even though it is cloudy, it is still raining. Let P be, it is cloudy. Q be, it is still raining. Then the symbolic form of the given statement is P and Q. Write the truth values of the following statements. Earth is a planet and Moon is a star. Answer. Let P be, Earth is a planet. Q be, Moon is a star. The symbolic form is P and Q. The truth values of P and Q are T and F, respectively. T and F is equivalent to F. Thus, the truth value of P and Q is F. 16 is an even number and 8 is a perfect square. Let P be, 16 is an even number. Q be, 8 is a perfect square. The symbolic form is P and Q. The truth values of P and Q are T and F, respectively. T and F is equivalent to F. Thus, the truth value of P and Q is F. A quadratic equation has 2 distinct roots or 6 has 3 prime factors. Let P be, a quadratic equation has 2 distinct roots. Q be, 6 has 3 prime factors. The symbolic form is P or Q. The truth values of both P and Q are F. F or F is equivalent to F. Thus, the truth value of P or Q is F. The Himalayas are the highest mountains but they are part of India in the northeast. Let P be, the Himalayas are the highest mountains. Q be, they are part of India in the northeast. The symbolic form is P and Q. The truth values of both P and Q are T. T and T is equivalent to T. Thus, the truth value of P and Q is T. Hope you understood. It's a wrap up for today. Thank you.